Alrighty then. I'm going to go over some of these Punnett squares with you guys. I'm going to do it in class as well. But in case you couldn't hear me, you're absent, or you weren't paying attention, well, here's another opportunity for you to learn how to do it. All right, so here's the first one. It's called a monohybrid because we're just looking at one trait. Here we're looking at the eyes of guinea pigs. Black eyes are dominant. So big B for black eyes, little b for red. Show a cross between a homozygous dominant. Now, if you don't know what homozygous is, whoops, you're in trouble. We're using B's. Homozygous means same, so it's going to be big B, big B. And we're going to cross that with a red-eyed male. Well, since red is recessive, there's only one possible genotype this guinea pig could have. It's got to be little b, little b. Boom, we found the genotypes of the parents. And that's the first step. All right, so I'm going to put the big B, big B. I'm going to put these, you can put them on the top or the side, doesn't matter. I'm going to put, here's this guinea pig. It might be the female or the male. I'm going to put its alleles on the top. I'll put the other one on the side. Little b, little b. And then it's just filling in the boxes. Because remember, each one of these guinea pigs are going to give one or the other of their alleles. Now, they happen to be the same, so it really doesn't matter. But this box is going to be big B, little b. They're all going to be big B, little b. Because both of them are homozygous with both of their alleles. So they're all going to be big B, little b. Genotypic ratio, all that is, hey, what are the percentages? What are the odds of getting this specific genotype? Well, you can see they're all the same. All these are all the same. So for these two guinea pigs, it's going to be 4 out of 4, or 100%, are going to have the genotype of big B, little b. Boom. Phenotypic ratio, all that's saying is, hey, what are these guinea pigs going to look like? Well, since black eyes are dominant, and they all have one black eye allele, 100% are going to have black eyes. Black, oh, it's hard to do this. Eyes. All right, so that's a ridiculously easy one. B, and this is what your test is going to look like. This isn't your test, but it's going to look exactly like this. In some cacti, green flowers are dominant to white. So green is dominant. Big G for green, little g for white. Cross a heterozygous green. Oh no, I forgot what heterozygous means. Well, you'll be out of luck if you don't know these terms. Good thing for you, I know what heterozygous means. Heterozygous means different. So I need 2 different G's for this cactus. I need a big one, a dominant, and I need a recessive one. Boom, there's a heterozygous green cactus. And we're gonna cross that with a homozygous white. I didn't even have to say homozygous because the only way you can have white flowers, you got to have 2 little G's. Little G, little G. Boom, I found the genotype of the parents. So now I just I'll put the big G, little g on the top. Big G right here. The cactus can give the big G to its baby plants, or it can give the little g. The other cactus just has little G's. So a little G here, and I wish this thing would get out here. There we go. And a little G here. And I'm going to switch to typing because it's easier to type. There's just fill in the boxes. Big G, little d. Little d from the left, little g from the top. This cactus over here. Big G from the top, little d from the left, and little d, little d. Phenotypic ratio. You can see right here, it's easy. 50% or 2 out of 4 or 1/2 of the little cacti will have big G, little g, heterozygous. And the other half are going to be homozygous recessive, little g, little g. All right, so here we go. Genotypic ratio, you can put 2 out of 4, or you can say 1/2, because it means the same thing, or you can say 50% of the new cactuses will have the genotype big G, little g, and the other 50% will have the genotype of little g, little g. Phenotypic ratio, all that's saying is, hey, what are these cacti going to look like? What are these cactuses going to look like? These guys right here, since they have a dominant allele, you can see it right there, 50% of them are going to have green flowers. So 50%, or 2 out of 4, or 1/2 will have green flowers. And the other 50%, the ones on the right, the little d, are going to have white flowers. All right, this one right here, Incomplete dominance, we haven't gone over that yet, so I'm going to skip that one. We're going to go over that in genetics too. Here's the big guy. Now for regular bios, this is going to be extra credit. For honors, you got to be able to do this. All right, so let's try it. So now we're looking at two traits at once. We're looking at where the flowers are at. You don't even need to know what this means. Axial means like the flowers are kind of like halfway up the plant. Terminal means the flowers are at the top of the plant. But we're also going to look at not only where the flowers are at, but also are the plants tall and short. So we're looking at two traits at once, not just one trait like eye color or flower color. We're looking at two traits at once. All right, so here we go. The first one is hybrid axial. Now, if you know what hybrid means, you're in business. If you don't, you might as well flip a coin or guess, because you got to know these terms. Hybrid means different. It's just like heterozygous. So it would be big A, or little a. That's hybrid, that's heterozygous, that's different. Big A, little a. But we're not done. That's the genotype for where the flowers are at. This plant still wants to know if it's tall or short, and it's heterozygous tall. If you don't know what heterozygous means, you're in trouble. If you do know what it means, you got a good chance. Heterozygous means different, just like hybrid. So it's going to be a big T and a little t. Think. There we go. I found the genotype of one of the plants. The other plant is homozygous axial. Once again, if you know what homozygous means, you're in business. If you don't, you're guessing. And if you have to guess from the start, chances are the whole thing's going to be wrong. All right, so here we go. Homozygous means same. And since it's axial, they're both going to be big. So it's going to be big A, big A. All right, so now we know the first trait's genotype, but this plant still wants to know if it's tall or short. And it's hybrid tall. You know what hybrid is? Good job. You know, that means just like heterozygous, it means different. So it's going to be a big T and a little t. All right, so there, we found the genotypes of the parents. And if you find the genotypes of the parents, I'm going to give you most of the points. Most of the points will be filling out the Punnett square. These over here are only going to be like worth 1 point each. So if you can find the genotype of the parents and then fill out the Punnett square, you're going to be in good shape. All right, so this is the hardest part. We got to figure out all the possible allele combinations for this genotype right here. Now remember, so I'm going to need 2 letters above each of these columns, and I need 2 letters on the side of each of these rows, because it's not going to be 1 letter anymore, like up here where we had 1, 1. Now we're looking at 2 traits. I need 2 letters, and there's going to be 4 letters inside the boxes, just like the parents. So 2 letters on top, 2 letters on the side, 4 letters inside the boxes. All right, so I'm going to find all the different variations of alleles in the gametes. So I need an A and a T. All right, so the first one, we use what's called FOIL. FOIL, F-O-I-L. So the F stands for first. This right here is the first A, and that is the first T. So one combination is big A, big T. Don't give me AA, don't give me TT. Because remember, Mendel's principle of segregation. You do not give both of your alleles to your offspring. You only give one or the other. So in this case, it's the big A, big T. All right, who else can the big A go with? It can't go with the little a, because remember, they got to separate. But the big A can go with the little t. Boom. All right, that's another combination. Big A, little t. Big A, little t. Let me switch colors. All right, we're done with the big A. It can't go with the little a. So we're going to move on to the little a. The little a can go with the big T. All right, that's another combination. Little a, big T. We got one more. The little a can also go with the little t. Right there. That's the last combination of A's and T's we got. Boom. So we're done with that plant. That's all the possible allele combinations for big A, big T, little t. And when it's heterozygous in both traits, that's always the hardest. Now this guy over here, big A, big T, little t, this one's only going to have 2 different allele combinations because he has 2 big A's for where its flowers are at. So one of the big A's, it does not matter. One of those big A's can go with the big T. That's one combination. Big A, big T. And now the other combination is one of these big A's can go with the little t. So it can be big A, little t. Now, if you want to do another big A, big T, big A, little t, you can, if you like to waste time. But most of us don't like to waste time. So we can cross out these boxes. We do not need them. All right, so now you just fill in the boxes. Switch back to typing. This right here, big A, big T, big T. Keep your A's together, keep your T's together. So don't go like A, T, T, A. Keep the A's together, keep the T's together. This one right here is fill in the box, big A, big T, little t. All right, now we go to this one right here. It could be big A from the left. Oh, let me get rid of that thing. There we go. Little a from the top. Big T from the left, big T from the top. Big A, big T, little t. Here we got big A. Oh, that thing gets in the way again. There we go. Little a, big T, little t. Always put the big letter in front of the little letter. So don't go big A, little t, big T. Try to put the big letters first. Over here, what do we got? We got big A from the side. We got big A from the top. Big T from the top, little t from the side. We got here. We got big A from the left, big A from the top, and two little t's. Get rid of that thing. What we got here? We got big A from the left, little a from the top, big T from the top, little t from the left. And right here we got big A comes first, little a from the top, little t, little t. Genotypic ratio, it's just saying, hey, how many of these plants have a certain genotype? All right, so I'm gonna start with this one. Big A, big T, big T. How many of them have that specific genotype? I see 1. So let's switch to typing. And there's 8 boxes. So 1 out of 8 of these plants will have the genotype of big A, big T, big T. All right, let's see the next one. Big A, big T, little t. There's 1. There's 2. That's it. 2 out of 8. Or you can put 1/4. 2, I'm going to go 2 out of 8. We'll have the genotype of big A, big T, little t. Let's go to the next one. How many are big A, big T, big T? There's 1. And that's it. 1 out of 4, or 1 out of 8. We'll have the genotype of big A, big T, big T. Let's go to the next one. How many are big, little? Big A, big T, little t. There's 1. There's 2. Boom. 2 out of 8. We'll have the genotype of 2 out of 8. We'll have the genotype of big A, big T, little t. Let's go to the next one. How many will be big A, little t? There's 1. And that's it. So on average, you cross these 2 plants, 1 out of 8 of the new little baby plants will have the genotype of, I forget which one it was. What was it? Big A, gotta figure it out. Big A, little t. I think that's it. All right, let's see. Yeah, sometimes that's why I put a little mark here to make sure I don't count it twice. And here's the last one. Big A, little t. There's only 1 of those. So it's once again 1 out of 8. 1 out of 8 will have the genotype of big A, little t. Phenotypic ratio, it's just saying, hey, what are these plants going to look like? All right, well, let's look. This one right here is going to be axial and tall because it has 2 dominant axial alleles and 2 dominant tall alleles. So is this guy. He's going to be axial and tall because he has 2 dominant axial alleles and 1 tall. You only need 1. Same with this guy. He's going to be axial and tall. Same with this guy. He's going to be axial and tall because you got 1 dominant axial allele. That's all you need because it's dominant. And 1 tall allele. That's all you need. That's it. So you count them up. 1, 2, 3, 4, 5, 6. 6 out of 8 are going to have the phenotype axial and tall. 6 out of 8. 6 out of 8 have the phenotype of being axial flowers plus tall plants. So what about the last 2? Let's see what they're going to be. These are both going to be axial. It's got 1 dominant axial allele. This one's got 2, but you don't need 2. You just need 1. It's good enough. But these are not going to be tall because look, they have 2 little t's. So they're going to be short. So 2 out of 8 are going to be axial and short. So let's do that. 2 out of 8 will be axial and short. All right. I know this one's kind of difficult, but hey, we got a lot of practice. I'm going to go over it in class as well for like 2 days. So do your best if you're at home. Try your best to get this, understand this. You can always come in for tutoring at lunch, Tuesday, Thursday if you need it. Email me with any questions, and I'll see you next time.